Chapter 1. The Automobile. Objectives. After studying this chapter, you will be able to identify and describe primary automotive assemblies and major automotive systems. Explain the frequent electronic interaction of major automotive systems or circuits. Describe and compare major automobile design variations. Identify and locate the most important systems used to operate conventional and hybrid passenger vehicles. Comprehend later textbook chapters with minimum difficulty. Technical terms. Accessory system, air-fuel ratio, assembly, automobile, body over frame construction, brake system, charging system, chassis, component, computer system, cooling system, drivetrain, electric vehicle or EV, emission control system, engine, exhaust system, frame, front-wheel drive, fuel efficiency, fuel system, gasoline injection system, ignition system, lighting system, lubrication system, mid-engine drivetrain, multi-cylinder engine, part, rear-wheel drive, safety system, starting system, steering system, suspension system, technology, track width, unibody construction, vehicle curb weight, vehicle height, vehicle length, vehicle weight, distribution, vehicle wheelbase, vehicle width. The term automobile is derived from the Greek word autos, which means self, and the French word mobile, which means moving. Today's self-moving vehicles are engineering marvels of safety and dependability. Over the last century, engineers and skilled workers the world over have used all facets of technology, or application of math, science, physics, engineering, and other subjects, to steadily give us a more efficient means of transportation. You are about to begin your study of the design, construction, service, maintenance, and repair of modern passenger vehicles. This chapter provides a quick look at different types of passenger vehicles and how they operate. By knowing a little about all major systems, you will be better prepared to learn the more detailed information presented later in this text. Today, a vehicle is as much electronic as it is mechanical. Failure of one computer-controlled system can affect the operation of a seemingly unrelated system. This makes a thorough understanding of the whole automobile and its major systems critical. Tech tip. Try to learn something new about the automotive industry every day. In addition to studying this book and doing all the hands-on activities, read automotive magazines, browse the internet, and watch motorsport television or internet programs. Increasing your knowledge daily will help you become a better technician with little effort. Parts, assemblies, and systems. A part, sometimes called a component, is the most basic type of removable item in a car. A part cannot be disassembled. An electric component is a part in an electrical circuit or system. An assembly is a set of fitted parts designed to complete a specific task. For example, the engine is an assembly that converts fuel into usable power to move the vehicle. Technicians must often take assemblies apart and put them back together during service and repair operations. An automotive system is a group of related components and assemblies that work together to perform a specific function, or job, or task. For example, your vehicle steering system contains the steering wheel, steering shaft, steering gears, linkage rods, and other parts. These parts allow you to control the direction of the front wheels and tires for maneuvering or turning your vehicle. Frame, body, and chassis. The frame and body are the two largest sections of a vehicle. The frame is the strong metal structure that provides a mounting place for all the other parts. The frame holds the engine, transmission, suspension, steering, and other assemblies in position. The body is a steel, aluminum, fiberglass, plastic, or composite, or carbon fiber. Skin forming the outside of the vehicle. The body is painted to give the vehicle an attractive appearance. The term chassis is often used when referring to a vehicle's frame and everything mounted to it except the body. Tires, wheels, suspension, brakes, engine, transmission, fuel tank, etc. In body over frame construction or full frame construction, the frame consists of thick steel members. The chassis parts and body bolt to the thick steel or aluminum frame. This heavy, strong design is used on some larger vehicles. Full-size trucks always use a full perimeter frame. With unibody construction, sheet metal body panels are welded together to form the body and frame, also called unit body construction or unitized construction. This is the most common design used to build passenger cars. Unibody vehicles are generally lighter and more fuel efficient than body over frame vehicles and have a high strength to weight ratio. General vehicle specifications. The following section describes common vehicle specifications. Manufacturers generally publish these specifications for each make and model of vehicle. Vehicle curb weight is the total weight of the vehicle with a fuel tank of gas and no driver. Vehicle curb weights vary. Generally, pickup trucks and SUVs are the heaviest vehicles and weigh about 2.5 tons. Full-size cars, station wagons, and full-size vans weigh about 2 tons. Compact cars have a low curb weight of about 3,000 pounds or 1,360 kilograms. Small sports cars and micro cars are the lightest passenger vehicles, weighing in about 2,000 pounds or 907 kilograms. You do not want to be in one of those in a collision. Vehicle weight distribution is a measurement of how much force is pushing down on the front compared to the rear tires of the vehicle. An ideal weight distribution for economy and cornering ability, or ability to turn a corner while maintaining directional stability, is 50-50 shades of anyways, or 50% front and 50% rear. A 50-50 shade of weight distribution can be found on many high-performance sports cars. Front-wheel drive vehicles have about a 60% front and 40% rear weight distribution for good tire traction with the road surface. Vehicle wheel base is the distance from the center line of the front wheels to the center line of the rear wheels. A typical wheel base for a full-size car might be 100 inches or 254 centimeters for a small compact car, and up to 150 inches or 381 centimeters for a full-size pickup truck. Track width is the distance between the center lines of the two wheels on the same axle. Right and left front wheels or left and right rear wheels. The trend is to make vehicles wider so they can corner more quickly without a rollover accident. Jeep, I'm looking at you. A typical track width might be 62 inches or 157 centimeters at the front axle and 64 inches or 163 centimeters at the rear axle. Vehicle length is a measurement from the outermost point on the front bumper to the outermost point on the rear bumper. Vehicle width is the distance between the two widest points from the right to left sides of the body measured perpendicular to the vehicle center line. Vehicle height is measured from the ground to the highest point on the roof line. Vehicle size. A full-size car is capable of carrying 4 or 5 adults. It usually has 4 doors and is rear or all-wheel drive with relatively large engine. Full-size cars are the heaviest passenger cars, but they still get slightly better gas mileage than most trucks and SUVs. A mid-size car is shorter and lighter than a full-size car, but it can still carry up to 4 adults comfortably. It often has a smaller engine and gets better fuel economy than full-size cars because of its reduced curb weight and frontal cross-section. A compact car usually has front-wheel drive with a small 4 or 6-cylinder engine. Compact cars are generally very fuel efficient because they are smaller and lighter than full-size and mid-size cars. The mini compact car is the smallest car allowed on public roads. It often seats only 2 people. Its wheelbase is very short, and the diameter of its wheels and tires is normally smaller than that of other vehicles. Their low weight and tiny engine make the mini compact car one of the most fuel efficient vehicles on the market. Vehicle body types. Automobiles are available in several models or body types. A sedan is a car that has front and back seats and will carry 4 to 6 people. Both 2-door and 4-door sedans are available. They have center body pillars or B-pillars between the front door and rear quarter panel. A convertible has a roof panel that can be raised and lowered into a storage area behind the back seat. The convertible roof can be made of metal, a composite, or a synthetic fabric. A convertible has no door pillars, and its strength is designed into the center area of the frame or floor pan. Convertibles are normally 2-door models. A hatchback or liftback has a larger rear door for easy access when hauling items. Hatchbacks are available in 3- and 5-door models. A station wagon has a long, straight roof that extends all the way to the rear of the vehicle. Station wagons have large rear interior compartments and come in 2- and 4-door models. A pickup truck is a front-engine cab-forward vehicle with a large open cargo area in the rear. Full-size pickups use a frame made of heavy gauge steel. The cab, bed, fenders, and other body panels are bolted to the frame. Rubber bushings fit between body panels and the frame to prevent noise and vibration from entering the passenger area. A full-size van has a large body for large families or commercial service. The minivan is a mid-size. It has a higher roofline for more headroom and cargo space. Most minivans are designed to carry 7 passengers. They are usually front-wheel drive. Sport utility vehicles are often equipped with 4-wheel drive systems and have a high roofline and floor pan. Because of the high floor pan, SUVs have ample ground clearance for off-road driving. They provide the comfort of a passenger car, the interior space of a station wagon, and the durability of a truck. Since an SUV is very heavy, with a complex heavy-duty 4-wheel drive system, it is not as fuel efficient as other types of vehicles. The crossover vehicle is a design mix. It is an SUV built on a passenger car chassis. The crossover is about half as tall as a minivan, which lowers its center of gravity for more rollover stability when cornering rapidly. The crossover also has a smaller cross-section for improved aerodynamics. Common names for various automobile body parts are shown in Figure 1-8. Note that a vehicle's right and left sides are denoted as if you were sitting in the car looking forward. I was not supposed to read that. Fuel efficiency. Fuel efficiency, or fuel economy, is a rating of how far a vehicle can travel on only 1 gallon of gas. Of fuel, or gasoline or diesel fuel. The EPA tests and rates cars to give them an average city and highway fuel economy rating. A typical fuel economy rating for a small economy car might be 40 miles per gallon, or MPG, city, and 43 miles per gallon highway. Estimated city EPA fuel economy testing is done with a preset number of stops, so the car has to accelerate to cruising speeds. Estimated highway EPA fuel economy ratings are for steady state interstate cruising speeds. Engine. The engine provides the energy to propel or move the vehicle and operate other vehicle systems. Most engines consume gasoline, gasohol, or diesel fuel. The fuel burns inside the engine to produce heat. This heat causes hot gas expansion, creating high pressure inside the engine to move its parts and produce useful power. Study names and locations of the engine parts in Figure 1-9. Automobile engines normally use a 4-stroke cycle. 4 separate piston strokes, up or down movements are needed to produce one cycle. Complete series of events. The engine converts heat energy or burning fuel into kinetic energy or spinning crankshaft. Automotive engines are multi-cylinder engines, which means they have more than one piston and cylinder. Today's vehicles can have 2, 3, 4, 5, 6, 8, 10, or 12-cylinder engines. Additional cylinders generally increase engine size and power output, but they lower fuel economy. The industry trend is to smaller engines with 3 or 4 cylinders. Computer system. The computer system uses electronic and electrical devices to monitor and operate various mechanical systems. Oh, fuck. Electronic controls are provided for the engine, drivetrain, suspension, instrumentation, restraint, and other systems. The use of computer systems has improved vehicle efficiency and dependability. Additionally, all onboard computers now have a powerful self-diagnostic capability. Today's vehicle computers can troubleshoot every major assembly, circuit, component, and system almost instantly. There are 3 major sections of a car's computer system, and I will get to you right after this call. Sensors. Sensors are input devices that produce or modify electrical signals with a change in a condition, such as motion, temperature, pressure, speed, location, etc. The sensors are the eyes, ears, and nose of the computer control system. Electronic control module. The Electronic Control Module, or ECM, is a small computer or complex electronic circuits. I don't know why I had to explain what this computer was. That uses signals from input devices or sensors to control various output devices or actuators. Each ECM serves as a small brain to determine needed outputs to actuators for the vehicle's operating conditions. Actuators. Actuators are output devices such as small electric motors or electromagnets. They can move parts when energized by an electronic control module. The actuators serve as the hands and arms of the computer control system. A modern car can have several control modules and dozens of sensors and actuators, all communicating or transferring data with a main computer processor. A main computer processor is a larger, more complex control module, or usually positioned under the dash, that can analyze electrical signals from smaller control modules wired into the vehicle's network. If any sensor or system control module detects a problem, it will signal the main computer processor so it can turn on a dash warning light. Tech tip: learn all you can about electricity and electronics. Now that an electronic network operates every major vehicle system, it is almost impossible to service anything on a car without handling some type of electric or electronic component. Fuel system. A fuel system consists of the components that store fuel and deliver a combustible air-fuel mixture to the engine cylinders. The system introduces the correct amount of fuel into the cylinders for efficient combustion or burning inside the engine. The fuel system must alter the air-fuel ratio, or percentage of air and fuel, with changes in engine operating conditions, or temperature, altitude, engine speed, load, and other variables. Gasoline injection system. A gasoline injection system meters fuel into the engine as needed. The engine control module reacts to the electrical data from the engine sensors. It can then energize each fuel injector to spray fuel onto the intake valve or directly onto the combustion chamber, depending on the type of injection system. A throttle valve controls airflow, engine speed, and engine power. When the gas pedal is depressed, the throttle valve is open for more airflow into the cylinders. Because more air is brought into the engine, the computer must compensate by injecting more fuel, increasing engine power output. When the throttle valve is closed, the computer opens the injectors for only a small amount of time, making the engine run slowly at idle speed. Electrical system. The vehicle's electrical system consists of several subsystems, smaller circuits, including the ignition, starting, charging, and lighting systems. Each subsystem is designed to perform a specific task. Ignition system. An ignition system is needed on gasoline engines to ignite the air-fuel mixture. It produces a high-voltage surge that jumps or arcs across the air gap at the spark plug tip at the correct time. This causes the air-fuel mixture to start to burn and expand in the combustion chamber. Starting system. The starting system has a powerful electric starting motor. The starting motor rotates the engine's crankshaft until the engine fires and runs on its own power. A battery provides the electricity for engine startup. The driver turns the ignition key to the start position, or presses an engine start button. Current then flows through the starting circuit to energize the starting motor. The starting motor then spins the crankshaft. As soon as the engine starts, the driver releases the key or button so the engine keeps running. With late model cars, the engine computer de-energizes and disengages the starting motor as soon as the engine starts and its speed increases. Charging system. The charging system is needed to replace electrical energy drawn from the battery. With a 12-volt battery, a belt-driven alternator generator forces electric current back into the battery when the engine is running. A voltage regulator, usually built into the alternator, controls the voltage and current output of the alternator. Tech tip. Most late model hybrid vehicles do not need conventional starting and charging systems with a separate alternator and starting motor. Instead, hybrids use a motor generator to recharge the batteries and crank the engine for startup. This reduces vehicle weight and complexity for added fuel economy and dependability. Lighting system. The lighting system consists of a vehicle's interior and exterior lights and all the components that operate them. Fuses, wires, switches, relays, etc. The exact circuit and part configurations vary from one make and model car to another. The exterior lights typically include the headlights, turn signals, brake lights, parking lights, backup lights, and side marker lights. The interior lights include the dome light, trunk light, instrument panel lights, and other courtesy lights. Cooling and lubrication systems. The cooling and lubrication systems are designed to prevent engine damage and wear. They are vital systems that prevent the engine from self-destructing. The cooling system maintains a constant engine operating temperature. It removes excess combustion heat to prevent engine damage and speeds warm-up of the engine. The water pump forces coolant, or water and antifreeze solution, through the inside of the engine, hoses, and radiator. The coolant collects heat from the hot engine parts and carries it back to the radiator. The radiator allows the coolant heat to transfer into the outside air. An engine fan draws cool air through the radiator. The thermostat controls coolant flow and engine temperature. It is usually located where the top radiator hose connects to the engine. The lubrication system reduces friction and wear between internal engine parts. It circulates clean, filtered oil to high friction points in the engine, such as bearings, camshafts, and crankshafts and pistons. The lubrication system also helps cool the engine by carrying heat away from high friction points between moving parts. Exhaust and emission control systems. The exhaust system quiets the noise produced during engine operation and routes engine exhaust gases to the rear of the vehicle body. Various emission control systems are used to reduce the amount of toxic or poisonous substances produced by an engine and fuel system. Some systems prevent fuel vapors from entering the atmosphere, air surrounding the Earth. Other emission control systems remove unburned and partially burned fuel from the engine exhaust. Drivetrain systems. The drivetrain transfers turning force from the engine crankshaft to the drive wheels. Drivetrain configurations vary depending on vehicle design. The most common drivetrain configurations are front-wheel drive, rear-wheel drive, and all-wheel drive. Front-wheel drive is commonly found on small passenger cars. A front-wheel drive vehicle has superior traction on slippery roads because the weight of the engine and transaxle is directly above the drive wheels. The front-engine rear-wheel drive configuration is shown. It is popular because the heavy engine is still in the front for safety. Front-wheel drive vehicles suffer from torque steering wheel motion affected by driveline torque. For this reason, rear-wheel drive vehicles have more precise steering than front-wheel drive vehicles. Some rear-wheel drive vehicles have a mid-engine drivetrain. The engine is located right behind the driver's seat with a transaxle mounted behind it. This provides for equal weight distribution on each tire for high cornering capabilities. A vehicle with all-wheel drive often has the engine in the front and twin differentials to distribute engine/electric power to all four wheels and tires. It has excellent traction on wet or snow-covered roads. Drivetrain parts. The drivetrain parts commonly found on a front-engine rear-wheel drive vehicle include the clutch, transmission, drive shaft, and rear axle assembly. The drivetrain parts used on most front-engine front-wheel drive vehicles include the clutch, transaxle, and drive axles. Clutch. The clutch allows the driver to engage or disengage the engine and manual transmission or transaxle. When the clutch pedal is in the release position, the clutch locks the engine flywheel and transmission input shaft together. This causes engine power to rotate the transmission gears and other parts of the drivetrain to propel the vehicle. When the driver presses the clutch pedal, the clutch disengages power flow. The engine no longer turns the transmission input shaft and gears. Transmission. The transmission uses various gear combinations or ratios to multiply engine speed and torque to accommodate driving speeds and conditions. First gear allows the vehicle to accelerate quickly from a stop. High gear ratios, 2nd through 6th, allow the vehicle to travel faster at lower engine speeds after each upshift, providing good gas mileage. A manual transmission lets the driver change gear ratios to better accommodate driving conditions and preferences. A manual clutch and gear shift lever allow gear ratio changes to be made by the driver. An automatic transmission, on the other hand, does not have to be shifted by the driver. It uses an internal hydraulic system and electronic controls to shift gears. The input shaft of an automatic transmission is connected to the engine crankshaft through an oil-filled torque converter or fluid coupling instead of a dry friction clutch. Drive shaft. The drive shaft or propeller shaft transfers power from the transmission to the rear axle assembly. It is a hollow metal tube with 2 or more universal swivel joints. The universal joints allow the rear suspension to move up and down without damaging the drive shaft. Rear axle assembly. The rear axle assembly contains a differential and 2 axles. The differential is a set of gears and shafts that transmits power from the drive shaft to the axles. The axles are steel shafts that connect the differential and drive wheels. Transaxle. The transaxle consists of a transmission and a differential in a single housing. Both manual and automatic transaxles are available. Front drive axles. The front drive axles connect the transaxle differential to the hubs and wheels of the vehicle. These axles are equipped with constant velocity joints, which allow the front wheels to be turned to the left or right and to move up and down. Suspension, steering, and brake systems. The suspension, steering, and brake systems are the movable parts of the chassis. They bolt or anchor to the frame or unibody and provide directional stability when maneuvering. Directional stability is the ability of a vehicle to corner, brake, and accelerate with minimal body roll and body dive. Poor directional stability will cause a car to skid off the road in a high-speed turn or to skid out of control during high-speed braking. Suspension system. The suspension system allows the vehicle's wheels and tires to move up and down with little effect on body movement. This makes the vehicle's ride smooth and safe. The suspension system also prevents excessive body lean when turning corners quickly. As shown in Figure 1-19, various springs, bars, swivel joints, and arms make up the suspension system. Steering system. The steering system allows the driver to control vehicle direction by turning the wheels right or left. It uses a series of gears, swivel joints, and rods to do this. Study the steering system parts in Figure 1-19. Brake system. The brake system produces friction to slow or stop the vehicle. When the driver presses the brake pedal, fluid pressure actuates braking mechanisms at each wheel. This action forces frictional material, brake pads or shoes, against metal discs or drums to slow wheel rotation. Accessory and safety systems. Common accessory systems include the air conditioner, sound system, power seats, power windows, rear window defogger, and navigation system. Common safety systems include seat belts, airbags, and security systems. Hybrid and electric vehicles. A hybrid electric vehicle, or an HEV, uses two methods of propulsion, an internal combustion engine and an electric drivetrain. An electric drivetrain consists of a high voltage, or HV, battery and at least one motor generator assembly. All major auto manufacturers now build and sell hybrid vehicles. Okay, when the HV battery has an adequate charge, the hybrid vehicle will operate in the all-electric mode, without the internal combustion engine ever starting or running. In the all-electric mode, the motor generator, powered by electricity from the HV battery, propels the vehicle. After the energy stored in the HV battery has been depleted, the motor generator fires up the internal combustion engine, which spins the motor generator's armature. This causes the motor generator to produce enough electricity to recharge the HV battery by linking the running engine's crankshaft to the transmission input shaft. The vehicle is propelled by the engine while the motor generator is spun by the engine to recharge the HV battery. What a mouthful. An electric vehicle, or an EV, has an all-electric propulsion system with no internal combustion engine. An EV must be plugged into a special battery charger to re-energize the high-voltage battery pack. Modern EVs have a driving range of several hundred miles before the battery charge is depleted. Summary. The body and frame support and enclose the vehicle. The engine provides dependable, efficient power for vehicle propulsion. The computer system uses electronic and electrical devices to monitor and control various auto assemblies. The fuel system provides the correct mixture of air and fuel for efficient and complete combustion. Electrical systems operate the electrical electronic circuits, components, and devices, as well as propulsion in hybrid vehicles. The cooling system maintains a constant operating temperature for improved combustion efficiency. The lubrication system reduces friction between moving parts inside the engine. Emission control systems reduce air pollution produced by the vehicle. Drivetrain systems transfer turning force from the engine crankshaft and or the motor generator to the drive wheels. Suspension, steering, and brake systems support and control vehicle handling, maneuvering, and acceleration. Accessory and safety systems increase passenger comfort, safety, security, and convenience. A hybrid electric vehicle switches between two methods of propulsion, an internal combustion engine and an electric drivetrain. An electric vehicle is equipped with an all-electric propulsion system and no internal combustion engine. I think that's it. Alright, that was chapter 1 of Modern Automotive Technology by James E. Duffy. Chapter 1, The Automobile. And that is finally it.